Alright, so today we are going to discuss about recursion. So what is recursion? As we can see on Google, the results are mainly recursion means repetition, and in programming language version we can say a function calling itself repeatedly is called as recursion. So we can see many definitions and many explanation on different websites. So better understand with help of an example, that's the best way. So let's see on IntelliJ. So whenever we talk about recursion, the first thing comes to our mind is factorial function. So let's understand with the help of that. We know factorial of 0 is equal to 1, and 1 factorial is equal to 1 multiplied by 0 factorial, which is equal to 1 multiplied by 1, which results into 1. So what's the value of 2 factorial? That's 2 multiplied by 1 factorial, which is equal to 2 multiplied by 1. As the value of 1 factorial is 1, so 2 multiplied by 1 is equal to 2. The value for 3 factorial, let's see, is equal to 3 multiplied by 2 factorial, which is equal to 3 multiplied by 2 multiplied by 1, and the result is equal to 6. So let's get the value of 4 factorial, which is equal to 4 multiplied by 3 factorial, which is equal to 4 multiplied by 3 multiplied by 2 multiplied by 1, and the result is 24. So yeah, here I think all of you can observe a pattern that value for n factorial is always equal to n multiplied by n minus 1 factorial. So this is the main formula for factorial, and let's see by implementing this function so we can better understand. Let's write a function public static int recursive function will pass in the num that we inputted from our user using scanner function. We use num value to calculate the factorial. So the base condition is that if the factorial value is 0 or num value is 0, if num is equal to 0, then return 1. As what we are gonna return is return num multiply by num minus 1, as we have seen in the formula. But with this num minus 1, we will again call this function recursive function over here. I'll tell you why in just a minute. So yeah, let's call this function in our main function system.out.println. We'll call this function recursive function and pass on the num value. Let's check by running this function. Let's pass on 4. The result is 24. As we all know, the value of factorial of 4 is 24. So this function is working fine. So let's understand what happened over here. So when we give a call, when we pass on 4 to our recursive function, then we check, the first condition we checked was, is the number equal to 4? No. So what we returned was num multiplied by recursive function. We again call the function. Let's write rf for the reference, and we call the factorial for 3. Now we don't know the value or the factorial value of 3. So again the function got called. Now the value that's passed on in the function is 3. As you can see, here's a function called. Now this gets added to call stack. Now 3 is not equal to 0. So again what gets returned is 3 multiplied by. Now again the recursive function is called, and the value that's passed on is num minus 1, that is 3 minus 1, that is 2. Now again we do not have the value for 2 factorial, so again the function will get called. Now 2 is not equal to 0, so again this function will get called. This statement will run, that is 2 multiplied by, this function will get called, that is, now 2 minus 1 is 1. Now again we'll check for 1. 1 will get passed over here. Is 1 equal to 0? No. So again this statement will run, that is 1 multiplied by recursive function. Now the value of 1 minus 1 is 0. Now we know the num value is 0. 0 is equal to 0. Now 1 will get returned over here. We have 1 as the input. So now 1 multiplied by 1, that is equal to 1. Now we have our factorial value for 1, which will get passed on over here. Now we have 2 value, factorial value of 2, which will get passed on over here, that's equal to 2. Now the factorial value of 3 is calculated as 6. Now factorial value of 3 will get passed on over here, which is equal to 6, and 4 will get multiplied with the factorial value of 3, and the result we will get is as 24. So this is how recursion worked in this case, and this is the base condition which is must have, so that a function do not enter into an infinite loop. And this is, we can see that we kind of backtrack, the values get added to call stack in this manner, and then when we reach the base condition, and then we start moving in the upward or the backtracking fashion and calculate the value for our final result that we need. So this is how recursion works, and this is a must have base condition. Let's see if we do not write any base condition, what will happen, just for fun. It will take a time some. Let's pass on 3 and see. We can see the error message as our function and entered into an infinite loop because there was no break condition, and the error we are getting is stack overflow error. So be pretty sure whenever writing a recursive function to write a break condition, so that you do not enter into this infinite loop. So that's it about recursion.